Okay, welcome to the memoization part, the memoization method for solving two-sum. So let's look at how Python dictionaries work behind the scenes. And I know you're thinking, why are we looking at dictionaries all of a sudden? Because we were just doing some for loops. Why are we using dictionaries? And also, isn't nouns an array? And I know you're thinking that, but let's just go through this and see what dictionaries really are. And it's going to be useful for us in a couple of minutes. So let's just see, let's just read this very nice article I just found on the internet, how dictionaries work in Python. And this is pretty general. Dictionaries also kind of work this way in other languages as well. Um, okay, so let's check it out. Mm, let's say you're writing a program that keeps track of phone numbers and contact names. You can store these pairs of information in a list like this, boom and boom, right? Even if you know the only you know the phone number of the person you want, your program will have to go through every item to find them, which makes sense, which is what we did in our brute force solution. We went through everything and saw if it was the number that we needed to reach the target. And when your list only contains two phone numbers, this might just be fine. What if you have a lot, right? And that's a common problem because in the world is really big, and you need to find find an efficient way to look through that data. So traversing the list index by index to search for the contact might take a long, long time. This might be a great use case for the dictionary, which looks like this. Here's a number, which is a key, and here's the value. Um, so Python dictionaries are like lists in that they can be made dynamically bigger as you add more items, but unlike lists, they have a super speedy lookup time. All you need to know to get the value is the key. So if you wanted the name of the person, as we see here, all we need to get to the name of the person is to get the right key. Pretty simple, right? Um, so let's look at what a dictionary really is. Right. So Python dictionary is also known as a mapping because you can use it to map key value pairs. For example, every spot in the dictionary, you have a value which is assigned to a key. So here's an example dictionary. Here's the key as we went through before, and here's the value that corresponds to the key. And all you need to access the value is to know the value of the key. And that's a little bit confusing. And I'm going to use another way to say it. So all you need to get access to the value is use the key on the dictionary to find that value. And it's a very fast lookup time. Here's another dictionary. It looks like this. First key, cool value. Second key, awesome value. Lots of keys, cool value. And you can have different values that have the same insides, the same value. And let's see here. Keys are the way that you look up items in a dictionary. They're required to be unique, so you can find the correct value when you use them for lookup. Values can be duplicated just like any above example since you don't use it for lookup. So look here, first key, right? That's unique. Second key, that's unique. Lots of keys, that's unique. Cool value and cool value, again, they're the same because, you're not using values to look things up. You're using keys, right? Okay. Just imagine if you were looking for somebody named John Doe and you wanted to find their phone number. So it's a kind of a reverse example. But there's a million John Does. How do you know which John Doe you're going to find, right? So John Doe wouldn't be a great key. And the design of the dictionary wouldn't be great either, right? Because you're not going to find the person. You want to find you want to use a key that's a unique identifier, right? And you're going to learn more about that in the future, or maybe you already know it and you're just watching this for fun, which I commend you for. Okay, so let's use a scenario to help us understand why looking up dictionaries is so fast. So you look for somebody and you can start at the bottom floor and knock on every door until you find her. So this would be O of N notation because you're going to have to look through all N floors of the building to find that person, right? Maybe you'll get lucky. Best case scenario, you're going to find her at the ground floor. So you just enter, boom, there she is, right? And maybe you're unlucky and you're going to have to go all the way up, right? And that sucks. So it would be great to have her office number, right? It would be great to have that. If you already know what floor she's on, you can just go to that floor first and look for her there, right? So the office number that she uses up is her hash value. And that's something, again, it's going to learn about later when you learn about hashing and stuff. But basically, when you have that key and it's implemented in a dictionary, the lookup is going to be fast. That's what you have to remember. So it's faster than if you were to look through every index in a list manually. In dictionaries, you can just say, I'm looking for this key, and you can get the value. And we're going to see how that works. So yeah, that's basically what dictionaries are. In here, you can still read a lot about more stuff about dictionaries and stuff, but that's the extent to what we need to know for this problem, right? Back to twosome. Cool. So memoization. Let's look through how we're going to go through solving this problem using what we just learned, right? And you can take a minute to think about how we're going to use this to solve. And I'm assuming you've paused. If you haven't paused, then pause now, pause again, or whatever. So let's go through this. Let's use dictionaries to solve this problem and see how it improves on our last runtime. Let's see how much it improves on that. Cool. So let's just call our dictionary, let's just call it dictionary dict one or dictionary one, just dictionary. And this is how you declare an empty dictionary in Python. This is how you make one. And right now it's empty. We still need to fill it up with stuff, right? We need to write stuff down into our memo. So for index in range len, and there's an extra parentheses here. And what you need to do here is add stuff in a dictionary. So take a moment to pause and ask yourself, what do we put as a key and what do we put as a value for this? Right? Think about what we need in our result, and think about what we have in our array and how we can use that in our dictionary, right? Okay, I'm assuming you've paused, and we can now go into putting stuff in your dictionary. So the correct answer is you want to put into your dictionary, you want your key to be the value that you're going to need, right? You want to see if the value that you need exists in your dictionary's set of keys, right? So, and how do we access that value, right? How do we access that value? Very easy. All you have to do is say nums of index, right? So dictionary nums of index is equal to, and what do we return here? What do we return for output? We're looking for the indices, right? So we're gonna match a number to its index. That's what we're gonna do in a dictionary. So that is simply equal to index, right? And now our dictionary should be filled with stuff. Very good. Now what we need to do is go through our array of numbers and see how to use this dictionary effectively, right? So for index 2, and it can be index as well, but I don't really care. In range len of nums, the same iteration as before. And here's the same deal, right? You still need a number. So you can say it is equal to target minus nums of index 2. And now the lookup is very fast, right? You don't have to go iterate through every value like we did over here, right? We had to iterate through every value. Now all we need to do, check if it's in there, right? Check if it's in there. So if need is in dictionary, and remember our second condition, right? The indices cannot be the same because you can't use the same value twice. So, and dictionary of need is not equal to index 2, right? And if this doesn't make sense to you, take a moment to pause and think about what each of these values represent. And dictionary of need does not equal to index 2, then you know that you've reached a condition and there's only one solution, so you can just return right away. Return an array, return a list of, and it can be in any order that you want. It's a dictionary of need, and this is the index 1, and index 2 is right here. So let's just see if this runs, if there's any weird bugs that we have. Global name num is not defined, line 27. Okay, so this should be nums. And this works, right? The order is a little messed up, but the order doesn't matter. So you can return the answer in any order. And let's just see how much faster this is compared to our brute force solution. Wow, that's really fast. And I did this problem a little while ago, and it ran even faster than that, so it was even more impressive, just like this. But as you can see, the memory usage was a little bit higher, and that's one of the cons of a dictionary. The memory can be a little weirder than if you just use one list. So anyway, hope that helped. If you want more documentation on how a dictionary actually works, feel free to Google it. But that's basically how twosome can be solved with both a brute force and a memoization solution. And I hope that you learned something. And something else to keep in mind is that there are definitely faster ways to do this as well. There are ways to do this in one loop, so you only need one for loop to get through everything. And I'll let you think about that. There are also other ways to creatively go about this, I'm pretty sure. So yeah, happy happy coding, guys. How do I stop this shit?